Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to start talking about Chapter 3, guys, but they, in the book, they kind of skip some little parts of equations that I kind of want to fine-tune and make sure you understand. They just start the book by assuming that everyone knows how to solve a 1- and 2-step equation. And sometimes that's the case, sometimes it's not. But I want to make sure that everyone knows. So I don't want to leave this for second guesses. So we're going to learn today how to solve just straight up single-step equations, okay? We'll worry about 2-step and multi-step in 3-1. But I want to focus in on 1-step equations today, so it should be nice and easy. First of all, a linear equation, okay? A linear equation is an equation that can be written in the standard form of ax plus b. I want you to notice something about this equation, though. Notice the x, okay? Notice that this x, which is the independent variable, has an exponent of 1. Now you may say, what are you talking about? I don't see an exponent. Yeah, I know. It's an invisible exponent of 1. Remember what we talked about several times, and I'm going to repeat it quite often. Remember that every number or variable is being multiplied by an invisible 1, divided by an invisible 1, and raised to an invisible 1 power. Okay? So when the power of the independent variable is 1, we are talking about a linear equation. Okay? And what happens is that the exponent dictates how many possible solutions you can have. So in a linear equation, since the exponent of the independent variable is 1, you're only going to have one possible solution. For a quadratic, if you guys remember those U-shaped graphs, the parabolas, if you remember there, you can have up to a possibility of 2 solutions. So the exponent tells you the degree of the equation and tells you how many solutions you can possibly have. Okay, how many real solutions you can have. Now, does that make sense to everybody? Right? So when the independent variable has an exponent of 1 and it's in an equation, that is a linear equation. Okay, so now let's talk about the goal. The goal of any equation, no matter what, is to isolate the variable. Get the variable all by itself. It does not matter how complicated or how simple the equation is. The goal of any equation is to solve for the variable in question, to get that variable all by itself. You don't want to solve for a negative variable. You don't want to solve for a variable in the denominator. You don't want to solve for 2 times the variable. You want to solve for the variable alone, by itself. You want to solve for x over 1 or p over 1 or w over 1, whatever the variable in question. But you want to solve for a positive variable in the numerator. Now, of course, you're not going to put x over 1, y'all. I'm just telling you this. You want to solve for x. But I want to make sure and clear that you understand that it's x in the numerator. You do not want to solve for 1 over x. No, you don't want that. You want x. You want to solve for positive x over 1, x in the numerator. Okay? Now, I know that this seems silly, and most of you are like, come on, Maura, I know that. Did you really, though? Did you really know that? Be careful the way you write things down. Please make sure that when I'm talking about the vocab and the meanings behind things that you really understand that. It's going to make your life a lot easier. And one more important note, very important note. Whatever operation is performed on one side of the equation must be done or performed on the other side of the equation. The best way I can help you guys visualize this is with a scale, or even better, doing weights. Okay? If you have a scale, like the scales of justice. Yes, sir.
If there was an addition equation, you could do the adding on the first part, then equals, and then let's say you do.
If you add 10 to one side, you have to add 10 to the other. Yes. It's just like a scale okay, or weights. If you guys are all you're gonna go do some weights, okay? And let's say you're gonna bench press, all right? And let's just say for giggles, you put 30 pounds on the left side and 30 pounds on the right side. Okay. Now it's not heavy enough, so you want to increase your weight. So you want to add 10 pounds. Do you add 10 pounds just to the left side? Do you add 10 pounds to the right side? Or do you add 5 pounds to the left and 5 pounds to the right? You add 5 pounds to the left, 5 pounds to the right. You have to keep it even, right? You always got to keep it even. Think of that as far as when you're working with equations. You got to keep it even, like when you're doing weights or scale. If you put 5 pounds on the left side of a scale, it's not going to shoot down and the other side is going to go up. How do I even out the scale? What do I have to put on the other side then? 5 pounds so they can even out, okay? So remember that equations are kind of like a scale or doing weights. Now, solving simple step equations. Guys, this is going to seem real simplistic to you, and many of you are going to say, why is this man even wasting his time with this? Again, I want no excuses. I want to make sure that every single one of you has all the basics you need to succeed. That's what's going to make me proud, making sure that I help you, okay? So number one, my brothers, you're going to undo addition with subtraction. It's that simple. It's literally that simple. If I have x plus 5 equals 9, I'm going to have to subtract 5 to both sides to get the x alone. You undo subtraction with addition. Literally, if I have x minus 5 equals 8, I'm going to add 5 to both sides to get rid of that negative 5. Undo multiplication with division. You undo multiplication with division. If I have 3x equals 15, I'm going to divide 3 to both sides to cancel out the multiplication. To both sides, of course. And last but not least, I undo division with multiplication. If I have x over 5, I'm going to multiply 5 to both sides to get rid of that division. Now, if you're looking at all these, hopefully some properties are coming into play. What property allows me to add the same value to a negative of that value and cancel it out? The additive inverse. Additive inverse is what allows me to complete both of these here, guys. Because if I have x plus 5 and I want to get rid of that 5, I'm going to subtract 5 to both sides. The additive inverse gives me the power to say 5 minus 5 equals 0. And then I can add negative 5 to both sides because I have to keep equality of the equation. What property allows me to cancel out multiplication and cancel out division? The multiplicative inverse. Very good. This is why we learned those properties, so you can see those connections. Now, literally, this is the lesson. Now let's just practice, okay? And I'm going to give you a lot of different types, a lot of types that people usually tend to make mistakes on, so that way you guys will not make those mistakes. So number one, we're going to start very nice and easy, okay? I have 27 plus n equals 46. So I want to get the n alone. I want to isolate it. I want to get it all by itself. So what do I have to get rid of? The 27. What's the sign of 27? So how do I get rid of a positive 27? That's right. So I literally subtract 27 to both sides, and n will equal 19. Now, if you don't know how to work with integers, I suggest you watch my integer operations video again, please, and thank you. Number two, I got 4 equals q plus 13. Same thing. How do I get rid of a positive 13? Subtract 13, but I'm going to subtract 13 to both sides, right? So then I'm going to get negative 9 equals q. Some people ask me, Mr. Morrow, can I rewrite that? Can I rewrite that like this? Q equals negative 9? Absolutely. There's a property called the symmetrical property of equality, and you can switch both sides as long as you keep the same negative. Okay, be careful with that. Sometimes people will say negative 9 equals q, but then they'll switch them and they'll go negative q equals 9. That's wrong. You're solving for q. Don't change that. Yes, sir. It doesn't really matter. Me, I'm a creature of habit. I like to read left to right. But that's me. That's not right nor wrong. Thank you, sir. Number 3, I got j minus 3 equals negative 7. How do I get rid of a negative? Positive. So I'm going to add 3 to both sides, keeping the equality. So j equals negative 4. How do I get rid of this 7.1 that I got here? Yeah, so you're going to subtract 7.1 to both sides. Remember that when the signs are the same, you add and keep the sign. So this would be negative 9.6 equals P. How about for number 5? How would I get rid of that negative 19? Yeah, you're darn right. Awesome. You're going to add 19 to both sides, y'all. And that will give you y equals 56. Yes, sir. Now, one thing I haven't been mentioning, and I guess I should, it's my bad. You can plug all of these answers back in, guys, and make sure it's right. That's the beauty of equations. So when you're taking an equation test, as long as you know how to add, subtract, multiply, divide quickly, efficiently, you'll have plenty of time to finish the test and go back, plug in your answers, and check. For example, if I plug in negative 4 here, what's negative 4 minus 3? Negative 7. We're good. It works. Make sense? Okay, now my favorite parts. Okay, now we're going to get into the multiplying and dividing. Okay, let's be real careful here. I'm going to do my best to make sure you're clear. All right, I got negative 7y. What's the relationship between negative 7 and y? They're being multiplied, so I got to multiply. Very good, my brother. So I'm going to divide by negative 7 to both sides. So y will equal negative 4. That's it. That's it. That's exactly right. Okay, I got negative 96 equals 4x. What's the relationship between the 4 and the x? How do you cancel multiplication? So I'm going to divide. Sorry about that, y'all. So I'm going to divide 4 to both sides. So x will equal negative 24. Negative 24. Be careful. Okay, now, this is a typo. Oh, no, it's not a typo. That's an equals, right? It just looks like it's, okay, let me just drop it down a little bit. Okay, guys, look. For this, okay, this is the one that I really got to make sure I get everyone's attention here. I have a denominator of 7, correct? Okay. It's division, right? What do I multiply by? Okay. Let me make sure you guys understand this, though. You're multiplying, whoa, let's move this guy over here. You're multiplying, really, 7 to the numerator, right? So make your lives easy, guys, and just multiply by the reciprocal. That way you know if it goes in the numerator or the denominator. Now 7 times m over 7, that cancels. M equals 7 times 12, because remember there's an invisible 1 down there, and that's 84. I can't tell you how many times the most popular answer here will be 12 over 7. Why do people do that? I'll show you. People will do this. They have the 12, right? And they'll go like this because they get lazy. And they go, oh yeah, okay, m equals 12 over 7. That is wrong. Do not do that. That is wrong. Help yourself. If you're multiplying 7 to both sides, does it kill you to show yourself that you're really multiplying by 7 over 1? That means that 7 is in the numerator. Please, guys, I know it sounds crazy. I know it does. I know it does. But please, trust me. I know what I'm talking about. Here, next, I got k over 4. I want to get rid of the 4, right? So how do I get rid of that 4? Yeah, you're going to multiply 4 over 1 to both sides. And now, guys, it's just fraction work. 2 goes into 2 one time, 2 goes into 4 two times, so that's negative 34. Moro, I wanted to multiply negative 17 times 4 and then divide it by 2. That's fine. It's going to take longer. I wish you would reduce your fractions for your sake, but that's fine. There's nothing wrong with that, and I'm not going to mark that wrong. It won't be wrong. It's right. And then how about this one? What's the relationship between 2 and x here? They're being multiplied, so how do I cancel multiplication? Here I'm dividing by 2 to both sides, right? So x equals negative 24. Now, I learn how to multiply, how to divide. Thank you. Negative 12. Now, one thing I wanted to show you. Well, actually, it's easier if I show you. Well, no. You can handle it. Okay. I'm dividing by 2, right, guys? But if I'm dividing by 2, what am I really multiplying by? Yeah, but give it to me in fraction form. Right. Isn't this really a 2 over 1 invisible? Right? So what did I say? Just multiply by the reciprocal. So x equals negative 24 over 2. Again, why am I trying to complicate it? I'm not. I'm trying to actually make it more simple, and I'm trying to make it consistent across the board. When you're left with a one-step equation, and you have a value being multiplied to that variable, whether it's a whole number or a fraction, and you want to get rid of that value, multiply both sides by the reciprocal. Let me explain again some more what I mean. Okay, now we get to the good stuff. You have two ways to do this, guys, okay? I'm a man of many versatile ways. You could first off say, okay, I want to get rid of this 3 in the denominator, so I'm going to multiply by 3 over 1 to both sides. You can do that. That cancels. That's 2x equals 54. Now I'm going to divide by 2. You can do that. That equals 27. There's not a darn thing wrong with that. Not a single thing wrong. You got rid of division with multiplication, then you got rid of multiplication with division. Perfection. So a few steps, though, could lead to errors. Could. I've seen it. Why don't we think about what Morrow just said? Is this a one-step equation? No, there's more than two things happening here. 2/3 is being multiplied to x, right? So how do I get something that's multiplied? How do I get rid of something that's being multiplied to x in a one-step equation? You're dividing by 2/3, but when you're dividing by 2/3, aren't you really multiplying by the reciprocal? State change flip. So guys, every time you have a one-step equation and you have a number in front of that x that's being multiplied, just multiply both sides by the reciprocal, and you're done in one fell swoop. 27. Done. 3/4 x equals 9. 3/4 is being multiplied to x. So let's multiply by the reciprocal. Now this only works when it's a one-step. When it's a two-step equation, you got to do something else. You got to break it down until it becomes a one-step. But in this case, this will equal, look how easy. Math is beautiful. X equals 12. So whenever I'm multiplying something to a variable in a one-step equation, simply multiply by the reciprocal. 2/5 x, okay, 2/5 is being multiplied to x. I want to get rid of that 2/5, so I'm going to multiply by 5/2 to both sides. X equals 10/7, very good, or 1 3/7. Does that make sense, guys? Now, either way, my brother, you can write it as an improper or mixed number. It depends on how they ask you the question. Thank you, my man. Now, 2 2/3 x equals 12/15. Please be careful. Many people are going to say, oh, cool, multiply by the reciprocal. You don't have a reciprocal of a mixed number. What do you have to do before you work with mixed numbers when you're multiplying or dividing? Yes, sir, my brother. And turn it into an improper. Good, man. So this is going to be 8/3 x equals 12/15. What's one nice, pretty easy way to get rid of this 8/3 that's being multiplied to x? Yes, sir, my brother. Yeah, you divide, so you're multiplying by the reciprocal, basically. State change flip. But instead of, look, guys, look. This is what I don't think you guys are seeing. Look. Yes, you're dividing by 8/3. You're dividing by 8/3. But then you got to go, this cancels. Then you got to go stay, change, flip. Isn't that the same thing as just multiplying by the reciprocal? That's the whole point, guys. I'm trying to make your lives easier. So when you have a mixed number, you convert it into an improper, which is definitely 8/3 x equals 12/15. Now you multiply by 3/8 to both sides. These cancel. X equals 3 goes into 3 one time. It goes into 15 5 times. 4 goes into 8 2 times. 4 goes into 12 3 times. So my answer will be 3/10. Make your life easy by cross-reducing. Does that make sense? Promise? Thank you, boys. Okay, now, when you have fractions and you're adding, guys, I'm sorry to say, but you're going to have to know how to add and subtract fractions. So, how do I get rid of a positive 1/3 that's being added to A? You subtract 1/3. It's exactly right. Beautiful. Now, my common denominators. This goes to 21. That goes to -7. Right? Hello? This goes to 21. And this goes to 14. 14 minus 7 is 7/21 equals A, but I can reduce. Take 7 away from both the numerator and denominator. So I've got 1/3 equals A. Does that make sense, my brothers? Next, I got x minus 4 2/3 equals 2 2/3. Okay, I got to add 4 2/3 to both sides. Something like this is nice and easy. You don't even need a common denominator. That cancels, so I've got x equals 6 4/3. However, what's up with this 4/3? We can't have that, can we? What does 4/3 turn into as a mixed number? Well, the 4/3 is 1 1/3, which you add to the 6. Very good. So that would be 7 1/3. That's exactly correct. Does that make sense? Talk to me, guys. This is what I'm here for. This is my job. This is my pleasure. This is my duty. You good? Okay. For 17, I just threw in some decimals just because you're going to have decimals sometimes. How do I move over or get rid of or cancel out the -5.3? Yeah, you add 5.3. So y equals 2, 1, so that's 14.2. And last but not least, how do I solve for h here? Yes, you get rid of a positive with a negative, so I'm going to subtract 2.8 to both sides. So h equals, we're going to add and keep the sign, so it's going to be -6.5. And bada bing, bada boom. That's it. Does that make sense? Any questions? So again, guys, I want to really, really bring home to you the most important part, I think, is the whole getting rid of fractions, okay? Or getting rid of anything that's being multiplied to x. If I have 3/8 x equals whatever, 1/9. Okay, yes, you are dividing by 3/8. But remember that when you divide fractions, it's stay, change, flip, right? So you're going to multiply really by the reciprocal to both sides. And that's what I really need you guys to understand. Now, this only happens when it's in a single step, when you're already down to this part. Yes, sir?
For some reason you did 14/21, but 2/7 is not.
Wait, where are we going?
It was 2/7. You changed it to 14/1. You multiplied the top by 7 and the bottom by 3. 6/21.
Actually, this should have been 6. Yeah, I'm sorry. I went with the crowd, and I messed up. So this would be negative.
1/21.
Yeah, this is wrong. Thank you. I apologize, internet people. I went with my crowd, and that was my fault. I should not have done that. So let me redo that. Thank you so much. So I've got 2/7 minus 1/3 equals A. This goes to 7. That 21, that goes to -7. This goes to 21. That goes to 6. You're absolutely right. So A equals -1/21. That was my fault for not double checking. Thank you so much. But now we go back to what I was saying here, guys. We got to multiply by the reciprocal. When we multiply by the reciprocal, the first fraction goes bye-bye, and I'm left with then 8/27. Remember that if I have a mixed number, I got to turn it into an improper fraction. Does that make sense? Thank you so very much. I hope you learned a lot, and have a great day. Bye-bye.